Hello learners and welcome to Natural Sciences lesson. So today we're going to be dealing with practice questions that are based on density, mass and volume. So then let's start. The first question given to us says, draw particles of a liquid and a gas. We are given particles of a solid. We're supposed to draw the particles of a liquid and also a gas, just to show the differences in terms of the particles and their spaces between them. So we know that if this is a solid, and here we're going to be drawing liquid, and then here we're going to be drawing gas particles. Now we know that in a liquid phase or in a liquid state, the particles there, they take up the shape of the container, and the spaces between the particles in a liquid state, they are slightly bigger than the spaces of a solid. So now let's draw. We're going to have this particle there, this particle there, this particle there, there. They take up the shape of the container in which they are in, and the spaces between the particles is slightly larger or slightly bigger than the spaces in a solid. There we go. Then the gas particles, we do know that the gas particles, they spread and fill the entire container in which they are in. And the spaces between the particles, it's much bigger as compared to the two other states of matter, the solid and the liquid. So if I have my gas particle there, or if I have another one there, another one there, another one there, and so forth. So we can see that the particles between the gas particles, or the spaces rather, between the gas particles are much bigger as compared to the spaces in a liquid particle or in a liquid state and also in a solid state. However, the particles that are in a liquid phase or the liquid state, they have spaces which are slightly bigger than the particles or than the spaces in the particles of a solid state. So then, our next question has to do with density more intensely. The question that is given to us here, it says, below is a table of different substances and their densities. We need to use the information to do the following calculations. So what calculations are they referring to? We'll see. We are asked here that which one or which is more dense, a chalk or a glass? So we are given the densities on this side. We are looking at the chalk and the glass. We're seeing that the density of a glass is 2.6 grams per milliliters, and then the density of a chalk is 2.36 grams per milliliter, which then tells us that glass is more dense. So which is more dense? It is glass. Then now, the next question is asking us to do a calculation. How do we do that calculation, and what do we use to do the calculation? We are given that we have a large glass marble, so the keyword there is glass. And you want to find out its volume. So we are given a glass marble and we want to find out its volume. So we measure the mass and find it to be 50 grams. So we are given the mass. So mass is equals to 50 grams. They are asking us to determine its volume. So remember the equation that we need to use, or the formula that we need to use to calculate, or when we're calculating density, it says density is equals to mass over volume. What is given? Remember the keyword was glass, so when you look at glass, we are given the density of glass, which is 2.6. So the density of glass is going to be 2.6, which is going to be equals to the mass that we have calculated, that we have measured, it's said to be 50. So 2.6 is equals to 50 over the volume. And the volume is what we are going to be looking for. So how are we then going to simplify for the volume? And to solve for the volume, we are going to cross multiply. We know that any number is always over 1. When you cross multiply, we are going to get that 50 is equals to 2.6 volume, or 2.6 V. So now that we have that, we have 50 is equals to 2,6 V for volume. We are going to divide both sides by 2,6, divide both sides by 2,6, so that the 2,6 can balance and cancel each other out, and then our volume is going to be 50 over 2,6. So we can press our calculator to see what that is going to be. So when you say 50 divided by 2,6, we get an answer of 19,23. If we're rounding it off to 2 decimal places, we get an answer of 19,23 milliliters, because we're looking for volume. It's in milliliters. So that's our volume for the glass marble. Next question. So our next question is asking us again to do a bit of calculations. We are told that we have 500 grams, a 500 grams block of butter at home, and we want to find out, we found out that its volume is 555 milliliters. What is the density of the butter? So remember the equation. Density is equals to mass over volume. So density is equals to mass over the volume. What are we given? We're given the mass of this block of butter being 500 grams, and we're also given the volume of this particular substance to be 555 milliliters. So a simple substitution, we are going to say this is 500 divided by 555, because the mass is 500 and then the volume is 555. Then we press our calculator again to check how much density that is going to be giving us. So 500 divided by 555, we get an answer of 0,90. So we get an answer of 0,90. And remember the units. The units for density we are given there as grams per milliliter. So this is our density for this block of butter that we have at home. Moving right along. Again, we still have the very same table, and now we have a piece of coal and a piece of coke, which are exactly the same size. And that means also they have the same volume of 100 milliliters. So question now is, which one will have a greater mass? Calculate the exact mass of each piece. So we are given these two materials. We have the coal and the coke, and we are told that their densities are there. For the coal it's 1,5, and for the coke it's 0.25. Remember the equation. Density is equals to mass over the volume. So starting with the coal, its density is 1,5, so we're going to write our 1,5. That is equals to, remember that we are looking for the mass of each of these substances. So now, mass over the volume, we are told that each of them has a volume of 100 milliliters. So this is going to be 100 milliliters. So again, this 1,5 is over 1, because any number is always over 1. If it doesn't have a denominator, it is always 1. So you're going to cross multiply and have that the mass is going to be equals to 1,5 multiplied by 100. And when we multiply 1,5 and 100, what do we get? We get an answer of 150 grams. Remember, when you're multiplying by 100, you're going to move the comma twice to the right. So we're going to get an answer of 150 grams. Remember, the units for grams are 150. So now, our next part, remember we are supposed to calculate both masses of these two substances. They are different, and because they have different densities, they will have different masses, or we don't know. Now, how are we then going to calculate the mass of the coke? We're going to use the very same equation, so let's just make space. We're going to use the very same equation, but then now, instead of now writing the density as 1,5, our density will then be 0.25 as it is given from the table. So density is 0.25 is equals to, we are looking for the mass, and the volume is given to be 100. So again, this is over 1. We are going to cross multiply, which then means that mass of coke is going to be 0.25 multiplied by 100. Remember, when we are multiplying by 100, we move the comma twice to the right. If it's 10, we move the comma once to the right. So when you press your calculator and multiply those two numbers, you get 25. So it's going to be 25 grams because we have just moved our comma 2 times to the right. So we're saying that the mass of the coal is 150 and the mass of this coke is going to be 25 grams. So before we move on to our next question, let's just quickly go for an ad break and I'll see you just after this.